everyone. Welcome you all another time with TCS NQT coding problems. Here we usually discuss all the coding problems that is coming, like some of the coding problems that is coming in TCS NQT, and they are from the already happened slots. So they are not from some slots that is already like right now going on. They are already from the previous slots, and we discuss here and we find how to solve the coding problems optimally, saving some space and time, and doing some extra credit from the console. So before that, I will request you to follow us in Instagram, in Discord. You can join us. There is a Facebook page for preference. You can like that. You can get in the WhatsApp group and the Telegram groups of Prepensta. You will get so many new things, like we are making a document where all the solutions for previously held TCS in NQT slots are given. Like there are so many things there, totally a cheat sheet you can say, because they are just previous questions, and the questions are with the same IQ pattern. uh, they follow the same thing. And also, if you buy Prepinsta Prime, you will be able to prepare for 30 plus companies, like 30 plus service based companies plus some product based companies also as well. And let us jump into the code. Now the first code we are going to discuss is supermarket price. At first, let me say there is actually no name of the codes. I am naming them as per my thoughts. That's it. So this problem says that you will be given a number, that is, let's say 5244. That is the number you have given, and now you have to multiply all the digits of the number. So you are doing 5 into 2 into 4 into 4. That will be 160, and you have to print that out. Now it's easy to take a number as integer or anything else. How to do this thing? Now this is actually a very easy problem. uh, you can do one thing. You can take an integer value. You are taking this, I am writing it in C++ obviously. Now you are taking this input, and then you were just checking while the number is there. You are doing in modulo 10, and then there is a p you have declared as 1. You are doing into equals to, like p equals to p into something, that thing, because that is the last digit of the number. Then you are doing n by equals to 10. In this way, at first you have 5244. When you do modulo 10, you get 4. Then you do by 10, the n becomes 524. Then again you do modulo 10, you get 4. Then also there are 5 2 remaining. Then you are getting 2, and at last you are getting 5. After that, n is not there, so while loop will not be iterating. In this way you can get 5 2 4 4, and then you can multiply them on in the p like you are doing, and at last you can print. You can do some other thing also, like you can take a string, and that's fun. You're taking a string instead of an integer. Why? Because in string you are taking the input for the number. Now 5244 here is actually a string. Now if you know what is a string, string is a character array or a container for characters. So in here they are not the numbers, they are the characters, the character 5, the character 2, the character 4, the character 4 as their ASCII values. Now how to get the number 5 from character 5? You have to do the ASCII value of 5 minus the ASCII value of 0, because ASCII value of 0 plus 5 is ASCII value of 5. So you will be doing this one and you will be getting 5. In this way you can take all the numbers. You don't need to modulo and divide. You just traverse to the string and you get all the numbers, and you just multiply them with your number, and that's it. It's so easy. Now this is the C++ code. Yeah, it is very big. I know. And then p is equals to 1 at first. Then you are taking the string s as input. Now we are doing for auto I in s. Now what is this? If you don't know, I is actually assigned with all the characters that is in S, because in C++, what is string? String is a class, but it is a container class. So whenever you are iterating automatically I in S, now S is holding some characters. So at first I will be S of 0, like the 0th index of S. Then in the next iteration I will be S of 1 till S of S dot length minus 1. If the length is 4, like 5244, here the length is 4 because there are 4 digits, so it will be S of 4 minus 1, that is 3. Also if the length is 4, the indexes are 0 1 2 3 till 3, so it will be taking the till the last character of that. So this is something you can write to save time, because if you write for int then I equals to 0, I is less than S dot length, then I plus plus, then you are using this S of I to everyone. There is totally no problem, but I feel it cool, so I use it. And now I is you don't need to write S of I is itself a character. Now automatically it is a character. Now you are doing p into equals to I, the character, minus the character of 0. You are getting the value at first 5244, so you are getting this 5. Now you are multiplying it with 1. So at first p is 5, then you are getting 2. P is 5 into 2, then 4, and then multiplied by 4, and then the string ended, so you are printing the multiplication value. So that's it guys. In C++, in Python it is rather also very small, taking the input as string, because Python default takes integers input. If you want to take integer input, Python default takes string input. If you want to take integer input, you have to write int of input, because then only the string will be converted into integer. But then also you can face problems if the string is actually holding a g k, like alphabets or some non-numerical stuff. Then p is assigned with 1. I is equals to like I, for I in n is the same thing like auto I colon s n. In Python you can assign I in n if n is something like a container, like string is a container, list is a container in Python. If n is an integer, then you have to write range n so that you can iterate it over n times. Otherwise you are taking n, because the n is the string, and from n0 to n length of n minus 1 is taken by I. Then you are doing this p into equals to integer of I. Now in C++, what we are doing, in C++ we are just doing this, but in here we will be taking this integer of I because it is easier. Because if you want to do the same thing in Python, you have to write order of I minus order of 0 and the character of it, actually not the character of that, integer of that. Or you can just do, yeah, that's totally fine. You don't need to do anything else, you just take this thing. Why do you want to write this whole thing? Because I is already a character, and that is holding a numeric value. So if you do integer of I, it automatically typecast the character to integer. It multiplicates with p, and at last you print p. The time complexity is O of n, because it depends on the length of n, the length of the string. The same thing happens with Java. You are taking the input in n, then you are doing raise equals to 1. Now I told you the first approach to solve the problem. Here I have used like the person who have done this coding have used this process, like result equals to result into in modulo 10. So you are getting the last value, then you are doing n equals to n by 10, so you are getting the raised value, the last value is gone. In this way you take all the last values, and at last when you are not left with anything, so n is not greater than 0, you print the result. So that's it. Here also the time complexity is O of n. they both are optimized. You can choose any of them. And let's jump into the next question here. This problem says about a hashing technique, like it is called a secret message. This says that a high profile secret agency wants to handle all the messages and do a cipher. Like they want to encrypt the messages in which A will be turned into F, B will be turned into G, C will be turned into H. In this way, Z will be turned into E. Now, if you look it very closely, A is actually shifted 5 times. Like what is A? A, and after that there is B, C, D, E, and then F. So A is shifted after 5 times and it is getting F. So it is totally like ROT 13, where ROT 13 is actually, if you don't know, ROT 13 is actually a shifting algorithm cipher where the characters shift 13 times. So whenever you encrypt something and decrypt something, you get the same thing basically. So like if you encrypt the thing twice, you get the same thing. So in here the key is 5, like A will be F, C will be H, till V, because whenever you are doing it with you get Z, because after you there are 1 2 3 4 5, only 5 characters. Then after you, what will you do? You will do from V, you will start doing it A, because after Z you again start from A. Like whenever you are reaching Z, you will again start from A. So U is A, W is B, X is C, and the same thing. You know how to do this problem, how to solve the problem in lower time complexity optimizedly. Suppose this is your input, like WORD, where W gets B, O gets T, R gets W, D gets I. In this way, BTWI. This is the encryption of this word. And also the encryption of reply is WJUQD, something like that. One kind of hashing you can say. Now, this is the C++ code. At first, I am doing this, I'm just declaring two variables, like two string variables. One is S, one is answer. Now at first, answer is a empty string and you are taking the input for S using getLine. If you don't know what is getLine, getLine takes a total line and gives this to the input, that is cin. Because if you take normal cin, it just takes like tilde space. That's why I prefer using getLine, so that you take properly anything, if even if it contains a space. Though in this problem it is told there is no space because you cannot encrypt any space. Now we are doing for auto I in S. You know what that means? It means that the characters of S will be assigned to I, where at first I will be S of 0, then I will be S of 1, in this way till S of S dot length minus 1. If the length is n, then S of n minus 1, that is the last index of S. And in this way you can assign all the characters to I. Now you can use I to see if I is less than equals to u, then only you are adding I plus 5. Now in C++, when you do a character and you add just a value, it shifts, like it shifts totally. But if you assign it to an integer, not a string, then it totally takes the value, that is the ASCII value of it plus that number. So in here we are just adding it to a string, so it will be taken as character. So when you do I plus 5, it will be shifting 5 times. So you know the ASCII value of A plus 5 will be A, B, C, D, E, F, the ASCII value of F. So that's why that takes the character of F. In Python you have to write something like char. I will show you in Python code. In C++ you don't need to write anything, it automatically will take I plus 5, that means the 5 shifted character. But if it is greater than u, that if it is V, then what you will do, you have to just again start from A, right? So because if you do V plus 5, then it will take the character after Z, and in ASCII value wise there are garbage values after Z. Like you don't need that, they are not properly garbage value, but for us they are garbage value. Now you are checking if I is less than or equals to u, then only you are doing this. Otherwise you are doing answer plus equals to I minus like the character minus the character of v, like the ASCII value of v. Whenever you are doing this, you are just shifting the total thing plus a. So suppose if it is v itself, so I is actually v. So what is happening here, you are doing v minus v, so you are just assigning it with 0 and then you are adding a, so it gets a. If it is something after v, like one value after v, then it will give 1 and then 1 will be added with a and it will give b. So in this way the shifting is happening. It's a very easy thing. If you have proper knowledge about ASCII values, I will ask you to take what is ASCII values and how characters are assigned to ASCII values, then you will totally understand what is going on in the total thing. And after that you are just printing the answer out. The time complexity is O of n because n is here the length of the string. And now this is the Python code. At first you are taking this empty string for answer, then you are taking this as input. Now in Python you cannot just write I is less than v, because in C++ it automatically takes the integer values whenever you are comparing two things like two characters. But in Python you have to use order to use the ASCII values, because order means the ASCII value of I or the character, like it means the ASCII value of v. So if it is actually, it is not v, it is u, and if it is it, then only you are doing answer plus equals to character of order of I plus 5. Now this means like at first you have order of I, that means the ASCII value of I, then you are adding 5 with it. Now you have the ASCII value of I plus 5, and now you have a ASCII value, right? Now what will you do with ASCII value? You have to convert it with a character, right? And you do it with this function. Like whenever you write str of an integer value, it automatically takes the string of that integer value. Whenever you do integer of an str, if this is possible as a number, it automatically takes integer value, otherwise it gives you error. So the same thing with character also, it takes the ASCII value and it turns it into character. Now you can add it with answer because answer is a string, character can be added with them, string also can be added with them. So it is just adding with the answer and the answer, like the answer string. Otherwise if this condition is not satisfied, then only and else answer plus equals to character of order of I minus order of v plus a. That's it, and you are printing the answer, the same time complexity. And this is the Java code for the same thing. You are taking just looking if it is like in here there is no problem with ASCII values. It is quite like C++. Actually Java is made from C++, so you can expect the same thing from both. So result equals to result plus the character version of str of character at I plus 5. Result equals to result plus character of str dot character at I minus v plus a, and the total thing is the same thing, and that's all. uh, the time complexity is also the same. So before jumping into the next session, like the next problem, I will like to tell you something about Prepinsta Prime. Here I will like to include something that is Prepinsta has this amazing thing that is Prepinsta Prime, where you can do courses. Like there are many courses, like my favorite part is the TCS remote internship with TCS Ion, because there's some official partnership with Prepinsta. And then there are popular skills like artificial intelligence, cybersecurity, one of my favorite, and then this big data, and also some popular languages, C++, Java, basic coding, intermediate coding, competitive coding, quantitative aptitude for, basically there is everything. Like this is a heaven or a Netflix. If you want to prepare for your placements, you can get at least 30 plus companies covered, both product based and service based, because there are many like service based companies like TCS, NQT, Ninja Digital, Cognizant, and things like that, LTI, Accenture, DXC, and there's go on. And also there are some companies like Microsoft, Goldman Sachs, Amazon. The courses are for them only, exclusively, if you want to prepare. And also there are interview preparation, group discussion, resume preparation. There are exclusive projects like Pokemon project, Amazon.com project, Zomato review analysis, things like that. And in this way you can just like Netflix movie recommendation, these kinds of problems, these kinds of projects. If you are a CS student, you can get this opportunity to study for your exams, because there are many DBMS course or operating system course, SDLC courses, computer networks, also for EC students. uh, there's pseudocode automata fix. If you know what is automata fix, you will be given a code, and then you have to fix what is the problem in that. Pseudocode is something like that, but there is no problem, you just need to print what will be the output. And there are some real interview experiences from them who has got the interview and cracked the job. And I will like to share that if you take the total thing, it is very much pocket friendly, and there are lots of content. We all upload videos each day, and videos are going on, like it is increasing every day. So I will like to tell you that there are some massive good content. And that's it. Let us jump into the next question here. This is one of my very favorite code that came in TCS NQT till now in the previous slots. And the name of the problem I have given bit toggle. Now I will like to say you that this is a very unique problem. It's not like you can do brute force. Yeah, you can do brute force, but I will teach you something that is far more better than brute forcing. And that totally includes something that is called beat masking. If you buy the Prepinsta Prime course, you will get tons of video on them. And let us jump into the code at first. Let's see what the code tells. Now Joseph has a number, and what he needs to do, he needs to flip or toggle all the bits in binary of that number. Suppose the number is 10. So at first 10 in decimal is what in binary? That is 1010. That is in binary. So it's base 2. Now if you toggle this, it will be what? It will be the 1200 to 1, 1200 to 1, and in this way it will be this. That means 5 in decimal. So how to do this thing? At first you will say there is a way where you can find what is the binary value of a decimal number. That is, you divide it by 2, you take the remainder, that is 0, you again divide it by 2, you take the remainder, like it will be 5, so you take the remainder 1, and it will be 2, you divide it by 2, it's 1010, by this way. So now you have to do, if it is 0 then you have to do it 1, if it is 1 then you have to do it 0, if 0 then 1, if 1 then 0. Now the number is 0101. But this is so boring, and it takes totally like log of n, where log base 2 of n actually. This is the time complexity that is taken by this problem, this conveniently this problem. But how to do it? It's not in log o of square root of n or anything, it's just o of 1. It's called the constant time problem. Like how to do the problem in constant time, no matter how big the n or how small the n is, it doesn't even matter. You have to just do something so that you can get the output. Now let us discuss something. What is the best way to turn a 0 to 1 and a 1 to 0? Yeah, you can say that there is something that is called NOT gate, and that does it very happily. like it turns 0 to 1 and 1 to 0 very happily. But in programming languages there are and, there are or, and there is XOR, but there is no NOT gate. So how to do this thing? Now let me tell you a very quick thing. If you let's say XOR 0 1, what will be the output? It will be 1. And if you XOR 1 and 1, it will be 0. Because what XOR does, XOR actually does see that if there is any change of value. So if there is 0 0 and you do XOR, it will be 0 because there is no change. If this is 0 1, it will get 1. If it is 1 0, it will get 1. And if it is 1 1, it will get 0 because there is no change, but there is a change, so the value is 1. Now how can we use that? If you XOR something with 1, if it is 0, it changes the value, so it gets 1. And if it is 1, it doesn't change the value, like it is not changing the value, so it gets 0. So from 0 you can get 1, from 1 you can get 0 if you just XOR something with 1. So now you know how to get something like that, like you can just XOR something and toggle a value. But in this way, suppose you have 1 0 1 0, like the binary form of 10, and you want to toggle all the bits. Now if you just use 1, uh, the last bit or the least significant bit will be toggled. Like if you do 10s or 1, it will just get 1 0 1 1. But what about the rest? So for toggling all the bits, you need all the ones so that you can perform a XOR. Now how to find this number? This is something that is all the bits are set, but how to find this? Now you can do one thing. You can do 1 1, and after that you put it as that number. Like if it is n, then n or equals to 1. So at first it was, it's like at first 1, then after that a left shift is happening, and if you know what is left shift, there is a 0 added, then you are performing this or operation with 1, so the last bit comes 1. In this way you can go all over the numbers, but still it will take O of log n. That means log base 2. So how to do this thing in O of 1? That is, suppose you have a number that is 1010. How many bits are there? Actually there are 4 bits that you know. Now you need a number that is 1111, like the 4 bits are 1. Do you know how can you get the number? If you take a number, there is all bits are set, and add 1 with it, it will just toggle all the numbers, like it will be 0 0 0 0, but at last there will be 1. So 1 is followed by the number of set bits in the number. Now how to do that? If there are n set bits in the number, so you can just do 1 left shift n or 2 to the power n, whatever, they all the same thing, and you can find 1 0 0 0 0. And after that if you do -1, you will get 1 1 1 1. So if you need n ones in a number, like a n bit number with all set bit, you have to do 1 left shift n -1, or 2 to the power n -1. In this way you can find a number. There are all set bits and also the length is n. Now how to get the length of the given number? You can use just logarithm. Suppose you were using logarithm, then this gives you something like 3 point something, because you know that log of 8 is 3, log of 9 is quite greater than 3 but less than 4, log of 10 same thing. In this way, after log of 16, in log of 16 where the base are always 2, you have to worry about that because it is computer, and log of 16 will be 4. So all the values here will be somewhere between 3 and 4. So now whenever we are getting something like 3 or more, we know that there are 4 bits. We know that. Now how to do this thing in programming? We can use the floor value of the number, like floor of log of n, log base 2 obviously, and then we can add 1. Suppose you are doing it with 4, so log of 4 is what? 2. The floor value is always also 2, and then you are incrementing the number, and that comes 3. Now if you turn it into binary, it will be 3 bits. You, let's say you need to do it with 11, log of 11. Now we know log of 11 will be something 3 point something. So if you take the floor value of it, it will just take 3. Like if you take floor value after point everything, it gets 0, and it takes this number only. Now you add it with 1, and it will be 4, and the binary version of 11 is 1011. So in this way, if you write log of n, log base 2 of n, and the floor value of 8, and then add 1, you get the length of the number, and then you can just perform XOR happily, and that will give you solution in O of 1. So let us see the code in C++. In this code, at first we are taking this n, like declaring the n and taking the input for n. Now we are doing one left shift, that is we are doing something 2 to the power k, where k is integer version, because float returns double, and you cannot use left shift with double, so you have to typecast it. In here I am just typecasting the total value. Now we know we have to find something 2 to the power minus k, 2 to the power k minus 1. So we are doing this thing, or you can say 1 left shift k minus 1. That gives us the value more complex, less complexly. And then uh, we are doing this k thing, where k is the integer version of floor of log of 2, and then plus 1. Just that. In this way you can get the value of k. You can do 1 left shift k. If you have watched the total thing fully, you understand we are getting for 10, we are getting 1111. That is what? That is actually 15, because 16 is 10000. So if you do 10 XOR 15, you get 5, because I told you when you have 1010, you XOR with 1111. The 1 1 gets 0, the 0 1 gets 1, the 1 1 gets 0, the 0 1 gets 1. Any bit that is here, that is toggled, because there is a 1 and you are doing a XOR, a bitwise XOR. So in here you are printing the bitwise XOR. Always use this parenthesis, otherwise they will give you error. And this is totally something new. It is called bit masking, and we have tons of videos on Prepinsa Prime over that. And I really wanted to show this, how to do this code. And the time complexity is actually not O of n, it's O of 1. The same thing in Python. Now for doing this thing, at first let me tell you, whenever you write something and it just you just take the integer value, it automatically in Python it automatically takes the flow value. You don't need to write flow or ceil. If that is ceil, then you have to write something else. Otherwise it takes flow value, and it is integer. You are doing something integer because it is returning a floating value, and it is typecasting it in integer. In Python these things are easy, like you don't need to keep it in parenthesis, and then you were just left shifting it and doing a -1, and at last you are printing the XOR. So the time complexity here is O of 1 also. The next problem we are gonna discuss is called bikers cross. Actually the problem statements say something about bikers and how they cross, so that's why I have named that as biker cross. Now here is one thing you have to know. What is a binary array? A binary array is that only contains 0 and 1 in its elements. Like this array that will be given in the input will be a binary array. They will be only consisting 0 and 1, where 0 means you are going north and 1 means you are going south. Like 0 means you are going south to north and 1 means you are going north to south. Now at first he will be given how many cars or how many bikers are there. Now let us say there are 5 bikers. The first one is going from south to north, and the second one is going from north to south, the third one from south to north, the fourth one north to south, fifth one north to south. So each one that is going the same direction will never meet. So we can just think that they will never meet. Now suppose this person at first starts going this direction, and this person at first starts going this direction. So now they meet some point. Now if this person starts going this direction, he will not meet this person because this person is starting after he has done. Now when uh, this is starting, after that these two, like, he will meet with these two because they have started after the 0. So in this way you can say the 0 will be only paired with the rest of the one that is after it. Like if you have 0, you have to know how many 1 are there after it. If you have 1, you have to know how many zeros are there after before that. So you can just do with any one thing. Like either you can choose 0 and count how many ones are there, or either you can choose ones, all the ones, and you can choose how many uh, numbers are there as 0. Now how to do this optimally? Like at first you can do it in O of n square solution, where you will take I, that will be going from 0 to n, you will take j, that will be going to I, from I to n, and then you will check how many ones are there for each 0. If the number a of I is equals to 0, then how many numbers are there for each thing, like from each I to n. If it is 10110, then for this one you are checking how many numbers are there, that is 1, and then you can add it with the answer. But this takes O of n square because for each number you have to traverse through the whole array. Now how to do this same thing in O of n? Let us see the solution. This is what you call the C++ solution, and this is quite optimized. At first you are taking the input for n, you have declared n here. Now I have declared 3 more variables here. At first are a, because I will not store any value for the array because they are not needed. So why just wasting some space in the console? You I will tell you something, like I will tell you that whenever you can manage to save some space, please do it. If you can do something in less space complexity, you will be given extra credits every time. So in this way we will not need any space or any space complexity. We can do it in O of 1 space complexity or with 0 auxiliary space. Like there are some 2 or 3 variables, but when whatever the value of n is, even if it is 10 to the power 9, it will not change, they will be just the same. So in this way, at first we have taken these 3 variables where c will be uh, the number of how many, let us see, like let us write down the code and you will understand. Now you have taken the input for n. Now you are taking this for loop from I equals to 0 till n minus 1, because you just want to beat with all the indexes, like you need all the indexes in here. Now you are taking scene is a. So suppose the input is 1, sorry, the input was 0 1 0 1 1. This was the input. Now suppose you are taking the input for scene a, so it is taking a equals to 0 at first. Now if a is there, like if there is any a, now a is 0, so this condition will not be satisfied, so this condition will be satisfied. So c will be c++. At first c was 0, now it is c++. Now after that you are taking another number, that is 1, and you are getting Sum if A is satisfied here, because A is now 1. Now sum plus equals to C. So sum plus equals to C, and at first C was 0. After you have done C plus plus, C, the value of C is 1. Now sum plus equals to 1. So sum was 1. Sorry, sum was 0. Now sum is 1. How this thing is happening? Actually, C is counting how many zeros are we encountering. Like for each zero here, all the ones will be counted as a collision. So at first we are counting the first zero, then whenever we are getting 1, we are adding the number of zeros here. Now after that we will be counting another zero, we will be doing C equals to 2. Then after we get this one, we will be doing sum plus equals to 2, because before this one there are two zeros that one will collide with. Now at last again there is a 1 and there is two zeros before that, so sum plus equals to 2. So at first sum plus equals to 1, then 2, and then 2. The output will be 5, that is needed totally. So this is the dry run of this code. This is a very easy code. Let me tell you once more. Like at first you have 0 1 0 1 1. It is the C is counting how many zeros we are encountering. At first we are encountering 1 0, so C plus plus C is 1. Then we are encountering a 1, so sum plus equals to 1, because 1 will encounter with one number of 0. Then we are getting another 0, so C is 2. Then again 1, so sum plus equals to C, that is 2, because this one is encountering with these two zeros. And this one also the same thing, so sum plus equals to 2. In this way we are getting 5. The solution is 5, and the time complexity is not O of n square. It is not O of n square, it is O of n, and the space complexity is O of 1. It's constant space, and that is the most optimal thing you can do in a code. This is in Python. Actually I have taken this L, but it doesn't have any work here. Actually I tried to do it in a different way. If you take the prime, you will see the second way I have done it. And also sum equals to 0, C equals to 0. The same thing in C++. As you don't need the use of I, so I have just taken this underscore, and A is equals to input, and sum plus equals to C. If A is there, actually A is int of input, but it works. Like if it is 0, it should work. And then C plus equals to 1. The same thing is happening here. At last sum is A. Sum is printed, and the space complexity and time complexity are the same. And this is the same thing in Java. Now using the scanner class, we are taking the input in n, the number of n, and after that we are taking this for loop. We are taking all the inputs for A, like in A, the variable A. If A is not equals to 0, then only we are doing sum plus equals to C. Otherwise C plus plus, like the value of C is incremented. Like the previous codes you have understood, like C is incremented for counting the 0. Then after that, if we count 1, then for 3 zeros I will see that 1 will meet with these 3 numbers, so sum plus equals to 3. And the same thing is printed at last, and the time complexity is O of n. So that's it guys. I guess it helped you, and thanks a lot for listening the total thing.